Okay, guys. Uh, Mechanics 1.9 to 1.12 course practice. Guys, here are the formulas you need. And also one more thing you need to know. For free fall, acceleration is equal to the gravity. If it's going up, then it's positive. I mean, it's negative gravity, because gravity is pointing down. If it's going down, it's positive gravity. Okay? Which is 9.8 or 10, depending on what's the given, yani. So yeah, that's basically all you need to know. And like the quiz is just like, yeah, just use your brain in the exam also, you're good. Okay, let's start. The diagram below shows the VT graph of a moving object. What is the acceleration of the object between 0 seconds and 2 seconds? Okay, so we know what's the slope of the VT graph, so we did this so many times, guys. V final minus V initial. I don't even want to, okay, V final minus V initial over T final minus T initial. V final is 4, so 4 minus 0 over 2 minus 0. That's equal to 2, so that's the acceleration. And what's the next question? What is the net displacement of the object? Okay, net displacement, the area under the VT graph. If it was XT graph, you'd have to cut each individual like section by itself and measure that by itself. But it's VT graph, so it's just the area under the graph. So it's a trapezoid, so base 1 plus base 2 over 2 times height, so 10 base 1 plus, so it's base 2 from 2 to 6, so that's 4, so 10 plus 4 over 2 times the height, which is 4. So it's going to be 10 plus 4, 14 over 2, which is 7 times 4 equals 28. So 28. Okay. A cyclist speeds up from 5 meters per second to 25 meters per second in 10 seconds. Then he travels at 25 meters per second for another 10 seconds. What is the total distance covered by the cyclist? So here there's two segments of motion. There's this one from 5, like this segment, and we have this segment. Okay. So for the blue one, we don't have the acceleration. So we're going to use the acceleration independent equation, which is V final plus V initial over 2 times the time. So this is the first segment. Okay. Now we're going to add the second one to it. Plus x equals Vt plus x0. This is x0. Vt is 25 velocity times time, which is 10. That's going to equal, this part is 150. This is 250. You can put on, you can't get 400. So that's 400 meters. Okay. A possible equation of motion of a particle moving in the positive direction at a constant speed. So constant speed is URM, and there's only one formula for URM. X equals Vt plus x0. So it's moving in the positive direction. So all they want is V to be positive. Everything else can be anything. So here, t squared, that's not the formula, so that's wrong. Negative 3, no, we need it to be positive. T squared, so that's wrong. Negative 6, so that's wrong. And here t was positive, so that's right, so it's the last one. Okay, at t equals 0, a spring gun is used to eject a ball vertically upwards at 12 meters per second from the top of a tower A. The ball reaches a maximum height B and falls back to the ground C. Neglect air resistance and take G equals 10 meters per second. Okay, so here it's gonna be the UAR formula, but it's free fall, so yeah, delta y. I use y because it's like the y-axis instead of the x-axis. But you can use x, you can use any letter, it's just a variable, okay? 1 over 2 a t squared plus v0t, okay? But what is delta y? Delta y, we know it's y final minus y initial, right? Y final minus y initial. What's y final? It's c, the ground, so the height is going to be 0. I'm going to, because it's 0 if you take c as the origin. If you take a as the origin, it's going to be different. You can take any point as the origin. It doesn't really matter. But I mean, I'm going to take c. So y final is 0. What's y initial? It's here. And what is it? It's the height of the building. So we'll just say h. So delta y is 0 minus h. Yeah? So delta y equals negative h. Right? So what do we have now? Negative h equals 1 over 2 a is the gravity, but it's negative because it starts off going up. So negative 10 time it hits the ball at 6, hits the ground at 6 seconds, so the time is 6. So 6 squared plus v0t was the initial velocity. It's 12 because that's what, like, how much it's ejected vertically upward. So plus 12. I need to clean up my hand. 12 times 6. Okay. So negative h equals, if you just put this on your calculator, negative h is gonna equal negative 108. And yeah, you can just cancel the negatives, so you get 108. Okay, two particles P and Q move along the lines shown below, directed positively from A to B and of origin O. Okay, initially particle P is at A and particle Q is at B. At t equals to 0, P moves from rest towards Q with an acceleration of 0.6 meters per second, while Q moves towards P at a speed of 4 meters per second with an acceleration of 0.2 meters per second. The two particles meet at time t. At what instant will P and Q meet? Okay. So P is at A and Q is at B. Yeah? P moves towards Q and Q moves towards P. And they meet at a point. We don't know what that point is. P has the, I'm just stating the given now, like making it clear. So P starts from rest and accelerates at 0.6 meters per second squared. 0.6, and here the acceleration is 0.2. Okay. So now, how do we find the position where they both meet? It's at xp. The position of P is gonna be equal to xq, the position of Q, right? Now, what is the position of P? I'm gonna use blue for P, okay, and I'm just gonna use black for Q. Okay. So okay, I'm gonna write like here to make it clear. Or should I zoom? Should I zoom out? No, the letters are too small. Okay. Okay, so first, let's find the position of P. What's the formula for URM? 1 over 2 AT squared plus V0T plus X0. So XP is equal to 1 over 2 A, the acceleration of P, which is 0.6, 1 over 2 times 0.6 times T squared, which we don't know. We're just going to keep it as a variable. T squared plus V0T, which is 0. So we're going to ignore it. Plus X0, which is -7. So let's just put -7. Also this, let's simplify 1 over 2 times 0.6. That's just 0.3. I'll just simplify this into 0.3. So the equation doesn't get too messy. 0.3 minus 0.3 T squared minus 7 equals, now the position of Q, 1 over 2 acceleration 0.2. 1 over 2 times 0.2 is just going to be 0.1. I'm just simplifying it so it doesn't get too messy. 0.1 T squared plus V0T, which is 4. I'll erase this so you have space. Plus 4T. Oh no, -4. Oh yeah, guys, this is -0.1. Because, what's it called? It's moving in the negative direction. And this is going to be and it's going to be minus 4T. T plus 4. Okay, guys. Now, we take everything to the other side to, like, make it, like, simpler to solve also, so you can use the quadratic equation on your calculator. Okay, so -0.1, take it here, so it's going to be 0.4 T squared minus 4. When you take the other side, it's going to be plus 4T. Plus 4 minus 4. Minus 4 minus 7 is minus 11. Equals 0. So this is the formula for when they're both going to meet. Now, when you put this on your calculator, you're going to get two answers. A negative answer and a positive answer. The negative answer, it's rejected. It can't be correct because time can't be negative. And the positive answer, it's like approximately 2.25. Yeah, so this is the correct answer. Okay. It's not in the options, so the quiz is wrong. Okay, I'll ask my teacher about it tomorrow and I'll let you guys know. But this is the correct answer, okay? But the correct answer in the quiz is 2.45, but that's wrong because then this would have to be 0.2. If this is 0.2, then you'd get 2.45. But the only way you get 0.2 is if this is positive and you subtract it from this. But this is not positive because Q is moving in the negative direction. Okay, guys? So the correct answer in the quiz is this. Even though it is wrong, this is wrong. This is the correct answer, guys, for this question. I think there's a problem with the quiz. I'm not sure, but yeah, I'll let you guys know tomorrow. Alright, guys, next question. Okay, drag and drop the correct answer to complete the sentence below. Yeah, so they just want the displacement. So we know VT graph, it's the area under the curve. Okay, so yeah, let's find the area under the curve. So this area is a triangle. So 1 over 2 base, which is 4, times height, which is 6. You get 12. And here, for the second one, the one down, it's a trapezoid. So it's base 1, which is 8. Base 1 plus base 2, which is between 10 and 8, so 4 or 2, plus 2 over 2 times height, which is negative 6. This gives you negative 30. So 12 minus 30, that gives you negative 18. So the displacement of the object is negative 18. A block initially moving at 20 meters per second is decelerating at a constant rate of 4 meters per second squared. What is the displacement of the block over a course of 6 seconds? Okay guys, so here we have all the information we need, yani. So we're just gonna use the UARM formula. So delta x equals 1 over 280 squared, and that's what they want. So this displacement equals 1 over 2 a, acceleration is 4, so 1 over 2, 4, t is 6, so 6 squared, plus v0t, so 20 times t, which is 6. Now see guys, it's decelerating, yeah? So you guys need to be careful that this is not 4 actually. This is negative 4. Okay? Be careful guys. So when you solve this on your calculator, you're gonna get, I think, yeah, it's 48. So yeah, it's 48. Okay, a Boeing 747 is an airplane that accelerates from rest to 80 meters per second at a rate of 2.5 meters per second squared. Drag and drop the correct answers to complete the sentence below. The distance covered by the plane is... Okay guys, here we don't have the time, so we're gonna use the time independent equation, which is v final squared, so 80 squared minus v initial squared minus equals 2 a, which is acceleration, which is 2.5, 2a delta x, which is what we want to find. So guys, just put it on your calculator, shift solve, and then you're gonna get delta x equals 1280 equals 1 0. That's what they want, so 1280. Okay, the second part B, the time needed for the plane to reach 30 meters per second. Okay, so v equals at plus v0. V is 30 meters per second, so 30 equals acceleration, which is 2.5 times 0.5t plus v0, which is just 0. So yeah. So guys, when you solve this, you're gonna get t equals to 12. But 12 is not an option. So again, this question and question 5, so question 5 and question 8, there's both something wrong with them in the quiz. So the answer in the quiz is 32, but the way you get 32, it takes 32 seconds if it's 80. If you put 80 into the velocity, but that's wrong, because they want the time it takes to reach 30 seconds. So the answer in the quiz is 32, but that's wrong. That's wrong. The correct answer is 12. They need to fix the quizzes. Okay. Based on the information in the table, the acceleration of the particle is... So this is the table, obviously. So the acceleration of the particle You can use v final minus v initial for any point, or just use the first two because it's easier. So 16 v final minus 20 over 2 over 1 minus 2, I mean, or 1 minus 0. 1 minus 0. The other way. So that's gonna equal negative 4. So the acceleration is negative 4. Now the equation of motion of the particle is given by x. Okay, so we know that the acceleration is 1 over 2 at squared. So 1 over 2 times the acceleration. What's 1 over 2 times negative 4? Negative 2. Plus v0t. What's v0? 20. Plus x0. What's x0? 1. If the motion of the particle remains unchanged, it will instantaneously come to rest at a time t equals. Okay, so we want it at rest, so v equals at plus v0. So v is 0 equals a, which is negative 4 t, plus v0, which is 20. So solve this, you get t equals to 5. That's the answer. T equals 5. Okay, if the motion of the particle remains unchanged, the particle will pass through the origin at a time given to the nearest integer as t equals. Okay, guys. So you're gonna put this equation, because this is the equation of the particle, yeah? Put it equals to 0, because that's the position, like it gives you the position. So you're gonna get two answers, a negative answer, which is rejected because time can't be negative, and the positive answer, which is 10.09, I think. So yeah, and they want it to the nearest integer, so it's just 10. Okay, the instantaneous acceleration of the particle at any moment is equal to the slope of the graph, so v final minus v initial. You can use any two clear points. I'm just going to use the last point and the first point. So v final is 30, negative 30 minus 10 over 10 minus 0. You get negative 4. So it's negative. The particle changes its direction of motion at t equals to what? So it's here, it's moving in the positive direction because velocity is positive. And then when velocity is negative, it's moving in the negative direction. So when is it neither positive or negative? When is it changing from positive to negative? At the 0. And 0 is at, what's this? 3? Oh no, that's 2.5. Yeah, 2.5. So yeah, 2.5 is the answer. 2.5. The time when the particle returns to the origin to the nearest integer. So when does it return to the origin? That means x is 0, and we're gonna use the equation of like the UARM equation. So x, which is 0, equals 1 over 2 at squared plus v0. So we know that x is 0. So 0 equals 1 over 2 times acceleration is just negative 2 t squared plus v0. You can get it from the graph. It's 10 plus 10 t plus the initial position is 50. 10t plus 50. The t and the plus look the same. Okay, wait. Put it on your calculator. So let me just put it on my calculator. Negative 2, 10, and 5. Or no, 50. You get a positive answer and a negative answer. The positive answer is 8.09. Also, I don't think the other one before it was odd, it was 10.09, but it rounds up to 10, you know? Oh, wait, no, nearest integer. Guys, this one I'm not sure if it's 7.09, but that, like, whatever it is, it rounds up to 10 at that, okay? Because, yeah, I forgot. A car moves along a straight path from A to B in 2 hours. It moves through the first 75 kilometers of its journey at 60 kilometers per hour and the rest of the journey at 80 kilometers per hour. The total distance covered by the car is, okay. So, okay, so A, and then it moves 75 kilometers. This is A. 75 kilometers, and then you don't know how much more, and then you get to B, which is at 80, right? So this is 60 kilometers per hour is per hour, and here it's 80 kilometers per hour. Okay, so how do we find how long it took to cover this distance? We're gonna do x equals vt plus x0, t plus x0. So here 75 is the x, equals v, we know it's 60, t plus 0. So t, you're gonna get is equal to 1.25, which means this part is in 1.25 hours. And then that means the second part is in 2 minus 1.25 hours, which is 0.75. 0.75 hours. Okay, so how do you find this distance? You do x equals vt plus x0 against the same formula. I'm not use the age. Against the same formula. So it's gonna be x, we don't know at this time, so x equals 80 times 0.75 plus 75, because x0 is 75. That's gonna equal 135. So 135. The instantaneous speed of the car 50 minutes after it has started its journey. So 50 minutes into the journey, which segment is it in? Is it in 60 or is it in like here? It's here. It's like in this side. Oh, why? Because the 50 minutes is less than 1.25 hours, so it didn't have time to get to the second segment here. So it's 60. Okay, the magnitude of the average velocity of the car to one decimal place is, average velocity is delta x over delta t. Delta x is 135 over delta t, which is 2. And they wanted it in kilometers per hour, so you don't convert. If they wanted it in meters per second, you convert. That's gonna equal 67.5. 67.5. Okay. The displacement of the car over 20 seconds. So it's just the area under the graph. So it's trapezoid. So base 1 plus base 2 over 2 times height. So 19 plus what's base 2? It's from like here. So 14 minus 5, 6, 7, 8. 14 minus 8. So 6. So 19 plus 6 over 2 times the height, which is 20, equals, wait, give me 2 seconds, I'll do it on my calculator. The calc. The calc. 19 plus 6 over 2 times 20. You get 250. Okay, 250. 250. The average acceleration, so delta v over delta t. So v final minus v initial, it's 0 at the end, it's 0 at the start. So it's 0. The distance traveled by the car is equal to the displacement because the car does not change direction. It stays in the positive direction. It doesn't go under the graph. A motorcycle moving initially from the origin at 2 meters per second in the positive direction accelerates at a rate of 0.4 meters per second for 60 seconds. Okay, so the velocity of the car at t equals to 30. So v equals at plus v0. So the velocity is equal to 0.4 times 30 plus 2. That's gonna equal 14. So it's 14. The average velocity. So average velocity is delta x over delta t. So first we need to find the displacement. So 1 over 2 acceleration, which is 0.4, 1 over 2 a t 60 at squared plus v0t, so t times 2 times 60 over 60. Okay, so let's see. This is the change in time. Delta x, it's delta x, and it's delta t. Because you do 60 minus 0. So let me just put on my calculator. 1 over 2 times 0.4 times 60 squared plus 2 times 60 over 60. You get 14. So that's equal to 14. Okay, guys, this question is the same as this one, yeah? 135, 60, and 67.5. The same everything, so 35, 60, and 67.5. Okay, the distance traveled by the sports car between instant. Well, I didn't even read the question. I'm going straight into the thing. Okay, a sports car is moving at a constant speed of 20 meters per second, passes by a stationary police car. After 10 seconds, the police car accelerates uniformly to a speed v in 10 seconds. So there's 10 seconds, okay? Then continues the pursuit at the same speed. The police car catches up to the sports car in 60 seconds. So guys, how much do we have in total? How much time do we have in total? This confused me when I was solving it. So you have this 10 seconds. And then you have, it started moving, right? So you have another 10 seconds and 60 seconds. But actually, this 10 seconds is in this 60 seconds. Like, you guys get what I'm saying? Like, I don't know how to explain it. Look, this 10 seconds is a part of this 60 seconds. So it's plus 60 seconds. So in total, there's 70 seconds. Okay? Anyways, the distance traveled by the sports car between the instance past the police car and the instance the police car catches up. So it took 70 seconds. The car had 70 seconds, right? So 20 x equals vt plus x0, so v, and t is 70 seconds, so 20 times 70, and x0 is 0, so that's just 1,400. So that's 1.4 kilometers, right? Now, for the police car to like catch up to the sports car, their position is the same because they're next to each other, or it's caught up, So 1,400, which is the position of this sports car, is gonna equal the position of the police car. Okay. Now here, guys, we're gonna have to. You guys are gonna have to focus for this point because I was confused with it. Okay, so here we're gonna use the acceleration independent formula because we don't know how fast it accelerates to reach v. So what is it? V final plus v initial, so 0 plus v, because we know v initial is 0 because the car starts from rest, over 2 times 10. Okay, plus, now it reached v. Wait, let me explain why, because the guys wasn't clear. Wait, let me restart the explanation. So what's the formula for position? It's vt plus x0. So first, let's do vt. Okay, v, we don't know it. T, we know it's 60 seconds. Okay, so instead of v60, let's just add 60v. No, wait, 50v. Guys, see, I'm telling you, it's confusing. 50v because the first 10 seconds, it's spending it reaching v. See, guys, like, plus how long it took to reach v, so v plus 0 over 2 times 10. I think. Wait, let me put it on the calculator to check it from. So 1,400. Wait. 1,400 equals 50 v plus x plus u over 2 times 10. You get 25.45. Yeah, so the answer is. Okay, guys, one more time if you guys don't understand, because I didn't even understand what I said. So look, x0. What's the position of the car when it reaches v? So the position of a car, if you don't have acceleration, is v final, which is v, plus v initial, which is 0 because it starts from rest, over 2 times the time. Okay, guys, it's this equation. Okay, guys, it's this equation. Right, it's this. Okay, so we use that to find x0. And this is just v times t. Why is t 50? Because the first 10 seconds were here. Okay? Okay, guys? Like, I don't think I can explain better than that. So the answer is, if you solve this on your calculator, shift solve, you're gonna get v equals to 25.45. So yeah, that's the answer. 25.4. I don't know why I don't round up the last digit. Oh. Confusing question. Alright, so the duration of phase 1 of the car's motion is gonna be, we need to calculate it, so v equals 80 plus v0. So from rest, so v0 is 0, plus 80, acceleration is 3, so 3 t plus 0 equals 18, because that's the v final. So t is 6. T is 6. The distance traveled in phase 1. Also, we also need to find the distance. So I think we need to use 1 over 280 squared, because now we have t. So 1 over 2, 3 times 6 squared plus v0t, which is 0, plus x0, which is also 0. So 1 over 3 times 6 squared, so 1 over 3, or 1 over 2 times 3 times 6. You get 54. 54. Okay, the total duration of the car's motion. So what's phase 1? 6 seconds. What's phase 2? We don't know. And the last phase is 9 seconds. So we need to find phase 2. We're going to use again the x equals vt plus x0, I think. Okay, so it moves 360 meters, so 360. That's the x equals vt. So 360 equals v, which is 18 times t. T equals 20. So 20 plus 6 plus 9. So 20 plus 6 plus 9. You get 35. 20. This one. Plus 6 plus 9. Equals 35. The distance traveled by the car. Now we need to find all the distances. Phase 1, we know the distance is 54. Okay, we calculate it here. Phase 2, the distance is 360. Okay, phase 3, we don't know it. So we're gonna use the time. No, we have the time. We're gonna use the acceleration independent equation. So v final, which is 0, plus v initial, which is 18 meters per second, over 2 times the time, which is 9. That's gonna equal 81. Okay, so 54 plus 360 plus 81. 54 plus 360. 60 plus 81. Wait, give me 2 seconds. I'll do it on the calc. Okay. 54 plus 360 plus 81. 495. So the answer is 495. Okay, a car loaded with gasoline moves away from a gas station at 60 kilometers per hour. Simultaneously, a motorcycle initially 500 meters away from the gas station starts moving at 40 kilometers per hour towards the car and the gas station. The car and the motorcycle are moving in opposite directions. Okay, guys, let's just draw it out so we can know what's happening. So we have the gas station. Okay, the gas station. Nice drawing. Okay, gas station, and then we have the car. We just draw car. Okay, car. So the car is moving away from the gas station at 60 kilometers per hour. 60 kilometers per hour. And the motorcycle is 500 meters away. So 500 meters. It's moving towards the thing at towards the car at 40 kilometers per hour. Okay, so the time elapsed when the two vehicles pass each other. pass each other, so their position is the same, right? So it's gonna be x car equals x motorcycle. So x car is vt plus x0. So it's gonna be x car equals, no, I'm not gonna even write x because they're gonna both be equal to each other. So 60, no. Guys, look how your answers are in seconds and meters, so you need to convert meters per second. So 60, I'm not gonna do the whole conversion now. Just do 60 over 3.6 over 3.6 because that's how you convert. Vt plus x0 is 0 equals 40 over 3.6. Negative 40 actually. Negative 40 over 3.6 t plus x0, which is 500. Okay guys, let's find t, so I'll just put it on the calc. 3.6 t equals negative 40 over 3.6 t plus 500. You get 18. So yeah, t equals 18. T is 18. The motorcycle passed the car how many meters away from the gas station? So for this, wait, let's just erase all of this. We need to see how we just plug t in either of the equations. They're both equal to each other. So just plug t into the motorcycle one if you want, or the car, it doesn't matter. So negative 40 over 3.6 times 18 plus 500. You can use the car equation or anyone, they're both equal to each other. So negative 40 over 3.6 times 18 plus 500. 300. It's equal to 300. So it's 300 meters away. Okay guys, that's it. Here the formulas one more time. Anyone want pictures? Okay. You guys, bye.